Good morning to one and all. Good morning to one and all. Myself, Vamshi. I am from the Tripoli branch. Today, I am discussing about the topic of the ring oscillator. Coming to introduction part of the ring oscillator. A ring oscillator it is a type of electronic oscillator consisting of an odd number of inverting amplifier connected into a loop. It is a electronic oscillator and it is a consisting of an odd number of inverting amplifier and it is which is connected into a loop, and it generates an output input signal whose frequency is determined by the propagation delay through the inverters. It is a output signal whose frequency is determined by propagation delay to the inverters. Ring oscillators are commonly used in digital integrated circuits for clock generation and frequency synthesis. Ring oscillator, which are usually commonly used in the applications such as digital integrated circuits for clock generation. For the purpose of clock generation, it is used in ring. It is used and frequency synthesis and frequency synthesis purposes also ring oscillators are used. Basic working principle. The working principle of the oscillator is the output of each inverter is fed to the input of the next inverter into the loop, creating a closed feedback path. The output and input creates a inverter in a loop and is creating a closed feedback path. Due to the inversion at each stage, the output signal oscillates between logic high and logic low levels. Due to the inversion of at each stage, the output signal and the input signal between these high and low logic level regions are there. The propagation delay of the inverter sets the frequency of oscillation of the ring oscillator. The propagation delay of the inverters sets the frequency of oscillation of the ring oscillator. Ring oscillator configuration. Configuration for the ring oscillator is it is typically consists of an odd number of inverters. The ring oscillator consists of the odd numbers of inverters with 3 or 5 inverters. It will be have 3 or 5 inverters with being common configuration. The number of inverters determines the frequency of oscillation, with more inverters leading into a higher frequency output. The inverters are connected in a ring topology, hence the name ring oscillator. The name comes from the ring oscillator because it will be connected in the loop in the ring shape. Because of this reason, the name came ring oscillator. And the frequency determination. The frequency of oscillation of a ring oscillator is inversely proportional to the total propagation delay to the inverter. It is the frequency of oscillation of a ring oscillator and it is inversely proportional to total propagation delay through the inverters. Increasing the number of inverters or increasing the propagation delay of each inverter leads to a lower oscillation frequency. It is by increasing the number of inverters and increasing the proportional delay of each inverter leads, it will be result in the lower oscillation frequency. The frequency can be calculated using the formula equal to F equal to 1 by 2 for the frequency determination. And coming to the advantages of ring oscillators, they have several advantages and disadvantages. Coming to advantages, it has ring oscillators are simple to implement using standard digital logic component. Ring oscillators are very simple and easy to implement the logic components in the ring loop manner. They offer good frequency stability and can generate square wave outputs with well-defined duty cycles. They offer good frequency stability and can generate square wave outputs with well-defined duty cycles. The ring oscillator gives a good frequency stability and it will also generate square wave outputs with a well-defined duty cycles. Ring oscillators are easily scalable and can be designed to operate at a wide range of frequencies. And coming to limitations for the ring oscillator, they have several limitations further, and ring oscillators are sensitive to variations in process parameters, temperature, and supply voltage, which can affect their frequency. Ring oscillators are sensitive to variations for the parameters and the temperature and the supply voltages, and which affect their frequency stability. They consume more more power compared to other types of oscillators due to continuous switching activity. Another oscillators also there, but this is the most widely used oscillator because it is very useful, it's easy to, and it has a continuous switching active. Because of this reason, many of them uses a ring oscillator only compared to other oscillators. Ring oscillators may exhibit jitter and phase noise, especially at higher frequencies, impacting their performance in sensitive applications. It will be reduced noise, especially higher frequencies. Impact and the perform may will be used higher efficient mode. Ring oscillator variants. Differential ring oscillator use differential amplifier stages. Differential ring oscillators have used differential amplifier stages instead of inverters for improved noise immunity and signal integrity. Instead of inverters for improved noise immunity and signal integrity will be there. Injection lock or ring oscillator incorporate additional circuitry to synchronize the oscillation frequency with an external difference signal. Injection locked ring oscillators incorporate additional circuitry to synchronize the oscillation frequency with an external difference signal. A delay lockout loop means DLL means a delay lockout loop structures combine ring oscillators with delay elements to achieve precise clock synchronization and phase alignment. Impact of technology scaling. Advances in semiconductor technology have led to miniaturization of ring oscillators and improved performance metrics. The technology day by day increasing, and the semiconductor technology have been increasing, and the oscillators also updated day by day. Shrinking future sizes enable higher operating frequency and a lower power consumption in modern ring oscillator designs. It will be shrinking the future sizes enable higher operating frequencies such as lower power consumption in modern ring oscillation designs, also designed further specific further. However, process variations and manufacturing defects become more significant challenges in nanoscale integrated circuits, affecting the reliability of ring oscillator based system. The process variations and manufacturing defects become more significant challenges in nanoscale integrated circuits, affecting the reliability of ring oscillator based systems are there. Future trends and developments. Research efforts are focusing on enhancing the noise performance and frequency stability of ring oscillators for high-speed communication. Novel circuit topologies and design techniques are being explored to mitigate the impact of process variation and improve the robustness of ring oscillator implementation. Day by day, our future trends of development increasing and developing, updating the oscillators for the various purposes also. For updating this, we can use for very useful and very easily we can use this. Integration of a ring oscillator with adaptive control mechanism and calibration is expected to enable self-turning and self-healing capabilities in future designs also. For future generation will be more self-designing for many purpose and easy to handle. Case study. Silicon different types of oscillator. In ring oscillator there are different types. This one, coming to first one, silicon ring oscillator. A silicon ring oscillator was designed using CMOS technology with 5 stages of inverters in a ring configuration. Silicon ring oscillator was designed by CMOS technology, and it will be 5 stages of inverter in a ring configuration. The oscillator exhibited a stable oscillation frequency of 100 MHz with a power consumption of milliwatts. The performance of the ring oscillator was characterized under varying temperature and supply voltage condition to assess its robustness. And next, differential ring oscillator. A differential ring oscillator was implemented using differential amplifiers for improved noise immunity and common mode rejection. It will be designed for the more improved noise immunity and common mode rejection. The differential configuration reduces the sensitivity. It reduces the sensitivity to supply voltage variation, and it also improves the signal integrity of the oscillator. The oscillator frequency and phase noise characteristics were evaluated in comparison to a traditional single-ender ring oscillator. Industrial applications of ring oscillator. Ring oscillators find applications in digital signal processing, clock distribution networks, and frequency locked loops in communication system. They are used in microprocessor, field programmable gate arrays, and system on chips devices for clock generation and synchronization. Ring oscillators are also employed in wireless transistor radio systems and high-speed data converters for timing control and signal processing functions. The challenges and opportunities for the ring oscillator: addressing the impact of process variations and environmental factors on ring oscillator performance is a key challenge for future design improvements. Opportunities exist for optimizing the trade-offs between power consumption, frequency stability, and noise performance in the ring oscillator implementations. Leveraging advanced simulations and tools and design methodologies can help in overcoming the design complexities associated with ring oscillator and circuits. Thank you.